Hey, AP Stats, Mr. Ellinger here, and I'm going through the notes today for Chapter 14, Advanced Probability. We're going to start it on this async day. We're not going to finish Chapter 14 on the async notes. And we're going to talk about the advanced OR rule first, and then we'll get to the advanced AND rule a little bit, but just a little bit. Okay, so we had the basic rules from last time. We had OR is plus, AND is times, not is 1 minus, at least 1 is 1 minus none, and the other like little advanced rules like probability has to be between 0 and 1 and things like that. And so why do we need advanced rules? And so and we're going to start with the OR and see why we need a better rule and where the basic rule is going to go wrong. And so so it says, let's start with OR. We said before the probability of A or B is, it's a probability of A plus the probability of B, right? And so normally I do this as in class. Unfortunately, I forgot to ask you guys this yesterday, and so I'm gonna just make up the numbers. I'll be honest. So we'd ask the students of the class. We say, okay, how many of you have a cat? And we've got 25 students in the class, and so maybe we'd get 10 out of 25 that said they had a cat. And I say, okay, how many of you have a dog? And these days it seems like it's kind of more, and so I'm going to say 20 out of 25. That might be a little high, but just going for it. And then I say, okay, so what's the probability that a randomly chosen student has a cat or a dog? And so according to the formula, we would say it's 10 25ths plus 20 25ths, which is 30 25ths, which is not possible, right? We can't have a probability bigger than 1. And so what's going wrong? It might be kind of clear to some of you, but some of you might be like a little bit like, oh, what went wrong with the formula? And so we're going to show you two different ways of looking at it. One is a thing called a Venn diagram. In a Venn diagram, you say, okay, everybody in the class, I'm going to imagine in this sort of abstract box. And we've got one circle, and everybody who owns a cat is going to be in that circle. And then we've got another circle, and everybody who owns a dog is in this circle. So when we said 10 out of 25 and 20 out of 25, there's 10 people who have a cat, and so there's 10 people in this circle, and there's 20 people who have a dog, so there's 20 in this circle. But that doesn't mean that there's 30 people altogether in these two circles, because you're counting some of those people twice. So for example, suppose we had, out of those 10 cat people, we had 8 of them who had a dog and 2 of them who just had a cat. The way I could mark that is I could say that there's 2 people who are cat, not dog, and 8 people who are in both the cat and the dog camp. And now with the dog people, there was 20 of them, and we know 8 of them are here, so I know 12 of them are there. So really there aren't 30 people between the two circles. There's 20, 22, just adding them up. There's 22 people. Now these are disjoint groups here. There's the people who only have a cat, the people who only have a dog, and the people who have both. And those are disjoint, so I could add those up and it would make sense, and I wouldn't be double counting. So the problem with adding 10, I'm not sure which way to do it, adding 10 and 20 is you're counting the same people twice. Just for the record, for Venn diagrams, I often like to put everybody who's left over, because there's some people who have neither. And in these hypothetical numbers here, there's 22 people there, so there must be 3 people who have neither. Now, another way to look at this is a thing called a two-way table, and this is an example here. And so you've got cat, yes or no, you've got dog, yes or no, and the total. Let's use these same fictitious numbers here to kind of illustrate what's going on. We know that 10 out of the 25 people have a cat. So cat, yes, but I'm going down to the totals here. I'm not breaking it down by dog. 10 of them have a cat, and 15 families don't have cats. And in the dog camp, it's 20 out of 25. So 20 families have a dog and 5 families don't. So now if I add the 10 and the 20, the problem is that I'm adding up the totals, and I'm adding up, when you're adding these up, you can add them up by row or by column. What's really going on is that I've got 8 families that have both. There's 2 who just have a cat and don't have a dog. There's 12 that just have a dog, don't have a cat. And then again, just like before, there's 3 who have neither. You can see this illustrates the exact same numbers as the Venn diagram. You can see the 2, 8, 12, 3 all showing up. What's a little nice about a two-way table is it shows the 4 things separately, and it also gives you a chance to total up the various groups. So it kind of gives you more information in the two-way table, like more information that's sitting there already worked out for you. In a Venn diagram, it's kind of simplified a little bit. And so there aren't as many numbers to deal with, and it's shorter and smaller, but it doesn't show as many things. So either one is fine. You don't have to be a specialist in either one of them. You should be a little familiar with each at very least, and you can have one that you kind of prefer doing. So when we add the 10 and the 20 to get our 30, when we did it before, we were adding the 8 twice. We were adding the 8 in this column, and we were adding the 8 in this row, and you can't count those people twice. So that's what's going wrong, both a Venn diagram look and a two-way table look, in why we can't do the addition rule this simply. Okay? So there's an advanced OR formula. So there's one that works in general that will help you out with this. And what it is, so notice I said if A and B are blank, then the probability of A or B is just the probability of A plus the probability of B. What A and B have to be is they have to be disjoint, which, remember, we saw that word last class, means there's no overlap. They don't have anything in common. So if the cat and the dog people didn't have any overlap, if there weren't those 8 people who have both, then we could totally add them because we wouldn't be double counting anything. Another word for this, it's just another word for disjoint, I'm just throwing it out there, is called mutually exclusive. Or it's a phrase, I guess, since it's 2 words. So if the 2 categories is disjoint, then A or B is totally probability of A plus probability of B. But in general, like if you don't know they're disjoint, then the probability of A or B is the probability of A plus the probability of B. But when I do that, I counted the people who are both A and B twice. So I'm going to subtract them off once. Probability of A and B. Like to see it in the dog and cat version from above, the probability A is cat and B is dog, has a cat and has a dog. The probability of having a cat or a dog is the probability of having a cat plus the probability of having a dog minus the probability of having both, not because I'm excluding these people, but I'm just taking them from being counted twice, and by subtracting them off once, I'm only counting them once. And you get 30 minus 8, which is 22 over 25. And the formula works. Why does it work? Because that's how many people have a cat or a dog. So cat or a dog is anybody who's in either one of these circles, and you can see it's 22. And cat or a dog would be anybody in the cat column or in the dog column, but not counting the 8 twice. So that's the general formula. And the way it's written on the formula sheet, don't have to memorize it, is they write it with those same symbols we saw before. So remember that this one stands for or, and this one stands for and. You need to know that to be able to read the formula sheet. Or, you might just remember that this is the or formula, and it just gives you a reminder that you have to subtract off something. Even if you forgot which symbol is which, this might be like a mental cue for you to go, oh yeah, I got to subtract off the ones I counted twice. So here's an example. It says, at a university, 60% of students use Macs. 60% use Macs. The rest use PCs. 67% are undergraduates. The rest are graduates. Create a two-way table for the information thus far. So I'm going to make a two-way table. So two-way table, what I do is I generally make them kind of 3 by 3 and then write stuff on the outside. So I'm going to say PC or Mac and then undergrad, under with 2 Ds, and grad, and then I'm going to have a total column. Put in the information that you can so far without, you won't be able to fill in the whole table, so you'll just be able to fill in part of it. Take a second and work in percentages. So we're going to say this is out of 100%. Pause the video, do it yourself. Try it. Okay, here's the answer. So 60% use Macs, so the rest use the PCs, and 67% are undergraduates, and the rest are graduates. And so this is all I could do so far because I don't know how many of the PCs are undergrad or how many PCs are graduate. It didn't break them down by category. It just gave me stuff about the totals. And so I wouldn't be able to figure it out. It'd be kind of like if I just gave you a Venn diagram and I just told you the totals, but I didn't tell you anything about the overlap in the middle. Okay, now here's an extra piece of information. 23% of the students are graduate students who use Macs. Now fill in the rest, and for the questions down here, I use G and M. G for graduate, M for Mac user. So fill out the rest of the table and answer these questions that are down below. I'm going to pause the video and I'm going to fill out all the answers so to make sure I finish on time. Faked you out. Pause the video. Do it yourself. Okay, it's Let's Study. I'm going to have to motor before Mr. Engel gets back to his classroom here. So probability of graduate or Mac is probability of grad plus probability of Mac minus probability of both. Basically what you're doing is you're saying what's the total number of graduate students and Mac students without counting the same people twice. And so you could have actually said, oh, it's these people, these people, these people, and added those all up. That would be fine. But the other way to use the formula, it would be this plus this minus both, because you wouldn't want to have counted those people twice. The second one, probably of GUM, that's the same question. That was a trick question. That it's like that's what the U symbol means or, and so it's the exact same thing. So graduate or Mac is that's exactly what this one's asking. What is this one asking? This says a probability of not graduate and not Mac. So not grad and not Mac means you're an undergraduate student who uses a PC. I can figure that out. An undergraduate who uses a PC, that'd be the 30% right there, and I can get it straight off the table. Okay, we're going to do a little follow-up video in a moment that's going to be about conditional probability, and we'll see that in just a moment. But I'll just put that into the next video because Engel's going to be here in just a second. Okay, anyway, thanks for watching this first video, and get ready for another.